Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The compound shown is 2-bromo 1,5-hexadiene, CH2 is equal to C, Br, CH2, CH2, CH is equal to CH2. It contains 2 double bonds and already 1 bromine atom. Moving on to the next step. Determine the reaction. 2 equivalents of Br to undergo anti-addition, electrophilic addition, across each of the 2 double bonds in CCl4 solvent. Each double bond reacts with 1 Br2 molecule via anti-addition, adding 2 Br atoms across each double bond. Moving on to the next step. Identify the new stereocenters created. Addition of Br2 to the terminal double bond CH is equal to CH2, the right end, creates 2 new stereocenters. The 2 carbons of that former double bond each bear different substituents after addition. Addition of Br2 to the CH2 is equal to C, Br, and the C, Br, carbon already has a Br and after addition becomes C, Br, Br, which has 2 bromines. This carbon is not a stereocenter. 2 identical Br groups on the same carbon means it cannot be a stereocenter. The terminal CH2 becomes CHBr, which also is not a stereocenter since the carbon at the end becomes CH2Br, 2 H's on terminal carbon. And for the final step, re-examine the structure carefully. The starting material from the image is CH2 is equal to C, Br, CH2, CH is equal to CH2, a 5-carbon compound, 2-bromo 1,3-pentadiene, or 2-bromo 1,4-pentadiene. From the image, there appear to be 2 CH2 groups between the double bonds. CH2 is equal to C, Br, CH2, CH2, CH is equal to CH2, 2-bromo 1,5-hexadiene. Addition of Br2 to CH2 is equal to C, Br, gives BrCH2, CBr2. The central carbon now has 2 Brs, not a stereocenter. The terminal carbon is CH2Br, not a stereocenter. Addition of Br2 to CH is equal to CH2 gives CHBr, CH2Br. The internal carbon, CHBr, is a stereocenter, R or S. The terminal, CH2Br, is not 2 H's. So only one new stereocenter is formed from this addition. With only one new stereocenter from the right side double bond addition, we get 2 stereoisomers, R and S configuration at that center. The anti-addition gives a specific relative configuration at the 2 carbons of the double bond, but since one of them, CH2Br, is not a stereocenter, only one stereocenter results, giving 2 stereoisomers total. Therefore, 2 stereoisomeric pentabromides are formed. Options B, C, D are incorrect because there is only one true stereocenter generated in the product, yielding exactly 2 stereoisomers. Therefore, the correct answer is A. Therefore, the correct answer is option A.